Welcome to the Brain Matters webinar. I'm Dick Moberg, your host for today's presentation. As usual, we'll first look at some upcoming meetings and abstract deadlines. We'll then show a video of our featured panelists, which you saw in this last slide, Dr. Emanuela Keller and Chris Strassel from Zurich, Switzerland. And then we'll take you on a little tour of some new things going on at Moberg. And then we'll have Q&A with Dr. Keller live in Zurich. And now a few meeting announcements. Here's some upcoming meetings. The neonatal monitoring meeting put on by Brigham every year is October 10th and 11th. And of course, the Neurocritical Care Society meeting is in October in Vancouver. We'll have more on that meeting in the interlude following the feature presentation. Neuroscience Convergence is in St. Thomas in November, sponsored by the Mayo Clinic. And don't forget your sailboat. Resuscitation Science is in Philly, our hometown, in November. Medica is in November in Germany, which is mostly a business-to-business meeting. And the epilepsy meeting is in December in Baltimore. And now a few abstract deadlines. Here are some deadlines. I won't read them. Check them out on the recording of this webinar, which will be on our website within a week of broadcasting. This is a good time to remind you about our newsletter, the Neuroscience Monitor, which will keep you up to date in neuromonitoring. This is the main source of info for our upcoming webinars and other events. So sign up anytime on our website. If you have an event or news item related to neuromonitoring and neurocritical care, please send it to us. In today's webinar, we take you to Zurich, Switzerland to visit the ICU of Dr. Emanuela Keller. This is the view from our hospital looking down on the city and the lake. For those of you who have been there, you know what a beautiful city it is. In addition to the quaint streets, good food, and its history, it's got one of the top universities in the world, ETH. It's also becoming a high-tech hub. IBM Research has been there for years, and when I was there last month, I seemed to stumble across what appears to be a new high-tech area with no fewer than 4 buildings with a Google sign on them. This is the environment needed to turn ideas into reality, and Dr. Keller will describe the idea she had for her ICU quite a few years ago and her success with it. Dr. Keller's idea was to develop an ICU cockpit, and she's managed to bring together the key ingredients to make it work. First, she implemented comprehensive high-resolution data collection. We've enjoyed working with her on that part. Next, she established partnerships with ETH, the university, which is just next door, as well as with IBM Research across town. And she received government funding for her project in order to demonstrate the concepts and launch the project into routine clinical use. Pretty much everything you need to make a project successful. So now let's go to Dr. Keller and Chris in a recorded video to describe their ICU cockpit.
Welcome everyone, my name is Emanuela Keller. I'm the head of the Neurocritical Care Unit here at the University Hospital in Zurich. We have a 12 beds unit and we are treating about 1,000 patients per year. Together with Chris Strassel, our IT specialist, it's a pleasure for me to present our project ICU Cockpit. Started in 2014, it is an interdisciplinary joint IT project between clinicians, researchers and data scientists at the University Hospital, ETH and IBM Research Zurich. In addition, we were actively supported by Moberg ICU Solutions to build up our infrastructure. The overall target is to provide an IT platform for computer assistance in intensive care and emergency medicine with the initial focus on multimodal neuromonitoring and the prevention of secondary brain injuries. The neurocritical care unit especially is a very challenging environment. Data up to a time resolution of 1000 Hz are generated by multiple biosensors and medical devices from different companies. Normally, they are lost for analytics for several reasons. First, no standards for data exports exist. Data formats are different. Sometimes only numbers with no labels and units are exported. Second, the data of different devices and from different manufacturers are not integrated and time synchronized. Furthermore, the ICU is a stressful environment. Up to 700 alarms per patient per day are generated even in a stable patient, mostly due to artifacts in biosignals. Electronic health record systems, which are commercially available, lack in terms of data resolution, usability, and they include no analytics for decision support. With these problems in mind, we have set up the project ICU Cockpit as an integrated IT platform for patient monitoring and therapy support in intensive care. Data are collected systematically, mainly by the CNS monitors, which are permanently installed at all our ICU beds. Chris Stressle, together with computer scientists of the company Supercomputing Systems, set up, and Chris further improves and maintains the infrastructure. Behind the wall for data encryption, we have the researchers from the university, ETH and IBM Research, developing algorithms for early alarm systems and therapy support. The algorithms are first validated on simulated signals and secondly in further patient data sets, with the ultimate target to have a running decision support system at the bedside. The results from the algorithms will be transferred into software and visualized for the medical staff at the bedside in real time. The IT infrastructure is demonstrated by Chris with the following slide.
Hi, my name is Chris Stressle. I'm coming originally from IT security and telecommunication business. I was hired for the ICU Cockpit research team as an IT engineer. And here I can apply all my IT knowledge to a really interesting research project. Now let me give you an introduction into the infrastructure of ICU Cockpit. On this slide, on the left side, you can see that we collect the data from the ICU. In the middle part, we do the data processing and storing. And on the right side, we have a development and laboratory environment where we can test and come up with new releases for our platform. A bit in more details, on the left side we have vital sensors or medical devices which we feed into the Moberg CNS monitor, which are collecting and normalizing the data for us. In the middle part we are processing this data, not only from Moberg CNS monitors, but also the live feed from video cameras. Here are our applications and ML algorithms applied and then fed back to the middleware, which prepares the data and sends it back to the front end. The front end can be on the bedside, but as well on any mobile devices. At the middle bottom side, you can see that we have data post-processors and the scientific access portal, so we can dump and prepare the data for scientists. They can develop new algorithms and test in our laboratory and development environment to validate the data. And then we apply the new releases to our platform.
So where are we today? Until the end of June, data from 425 patients, including the informed consent by legal representatives or the patients themselves, have been collected, which means that data from 4.4 million parameter hours are actually stored. Several algorithms for artifact detection, the prediction of delayed cerebral ischemia in subarachnoid hemorrhage patients, and automatic seizure detection have been developed. Let me present some first algorithms developed. With smart alarms, a motion-based algorithm for the detection of artifacts have been developed. Video cameras are installed at all beds. The field of view is divided into 3 parts: the patient's bed and 2 regions of interest next to it. The amount of motion induced by the patient and the nurse is quantified at 2 directions. If a certain threshold is exceeded, the alarm generated is classified as an artifact, which means as a green, harmless alarm. Otherwise, it is classified as a true red alarm. The algorithm was controlled by medical experts. They confirmed or declined the initial classification by the system. Up to now, 2,800 alarms have been reclassified by doctors on the ICU. The sensitivity of the algorithm to detect an artifact was 30.2%, which means that nearly 1/3 of the artifacts principally could be eliminated by this simple algorithm. At the other hand, we have a false positive rate for true alarms of 12.8%, which is problematic as true alarms might be missed by the algorithm. Further refinement of the algorithm is needed. Another application which is actually under development is the so-called stable state. The idea behind is that we want to take into account the interdependencies of data streams to estimate whether a patient is in a stable state or not. The organ systems are dependent on each other, and as for example in sepsis, the organism disintegrates like a house of cards. A stable state, for example, a 5 minutes period, is defined by a medical expert as the nurse at her shift start. The strength of the relationships of data are calculated, as well as the time delays of their strongest relationships. Finally, the strength of relationships as well as the time delays are represented by colors in a so-called Mondrian graph. For instance, the relationship between the arterial blood pressure and the ICP, or the cardiac output and the ICP, is represented by a blue color in the initial stable state. If a drop of blood pressure occurs, the ICP, depending on intact or defect autoregulation, might decrease or increase, which means the relationship between the parameters changes and accordingly the color changes. This simple visualization tool will just help the nurse or the doctor to estimate whether a patient with a barely or markedly changing color pattern over time is in a stable or unstable state. The ICU cockpit, furthermore, allows us to develop new neuromonitoring methods. We developed an ICP probe supplied with fiber optics for near-infrared spectroscopy. Data at the time resolution of 50 Hz obtained with the NIRS ICP probe are synchronized and integrated with measurements with conventional non-invasive plaster-based near-infrared spectroscopy sensors. This allows us to develop algorithms to eliminate the extracerebral contamination in transcutaneous NIRS. Furthermore, data are integrated with measurements from PTiO2 monitoring cerebral microdialysis, as well as systemic hemodynamics for multimodal monitoring. What are our next steps? Within the ultimate target to have a running decision support system at the bedside, the results from algorithms developed based on high-resolution data have to be visualized at the bedside in real time. In collaboration with the University of Applied Sciences Northwestern Switzerland, we have already developed a dashboard to visualize data streams, lab values, and results from our algorithms in an integrated and user-friendly way. Chris will shortly demonstrate the running system.
This is the first ICU Cockpit user interface, which was developed together with the supercomputing systems. What we see here is a live stream from a real bedside from the ICU. We can see parameters from different medical devices. At the top we have the arterial pressure, followed by the ECG and even EEG data streams. At the very bottom you can as well see P minimum and P peak from Hamilton block, which is a respiratory device. At the very bottom of the screen you can see a live feed of the patient. The picture is blurred for privacy reasons, and also the application is here active, which Emanuela Keller just described. So you can actually see the regions of interest in the middle, left and right side of the bed. We can switch to the alarms tab, where you can see that a bunch of alarms are already detected, and also the green ones are classified as artifacts. Let me show you the new ICU Cockpit interface, which was developed as a web application. This allows us to display it on any device, like a mobile phone, tablet or a computer. On this overview you can see all the bedsides in the ICU, as well at the bottom the collection of all the alerts and the annotations. This gives the medical staff a good overview over what's happening and how much alerts are happening during which time. We can also see some certain information about each patient that we would like to display on this screen. And if we click on a particular bed, we can go into more details and see the actual parameters and live stream of the vital signs, like ECG, arterial pressure, SpO2, and so on. In the middle part, we are able to add new applications, like this imminent forecast for complications. This data here is for demonstration purpose only, and you can, for example, see the chance for a seizure is a certain percentage, or the chance for a cardiogenetic shock is a certain percentage. We can also display the live stream of the camera, or display laboratory data. Basically anything we would like to visualize, which doesn't fit into the live stream at the top. At the bottom we have again the timeline for alerts and manual annotations. The user interface is highly customizable, so we are able to add and remove parameters as we on a user basis, and the profiles are saved as well.
Before that, with my very last slide, I want to thank all the collaborators in the project, the Swiss National Science Foundation, but as well all the other foundations which have supported the project since 2014.
Well, thank you very much, Dr. Keller and Chris. And at this point, I'd like to urge all of the listeners to get their questions in. And we'll now take a few minutes to look at some things going on here at Moberg, and then we'll be back to you live for question and answers. So our next webinar will be from Thomas Helt of MIT. He'll provide a review of ICP monitoring principles and then describe his work on developing a non-invasive method. He hosted the International ICP meeting in Cambridge in 2016, and I ran into him again at the ICP meeting in Leuven a few weeks ago, actually. He's made some great progress, and you'll hear about it in our next webinar. The date hasn't been set yet, but please register for it on our website, and we'll send you the date. The date will also be in an upcoming newsletter. As always, if you register, you'll get a link to the recording, even if you can't listen. And for something totally new, at least for somebody my age, I'll be hosting a weekly podcast starting in October. I've been working in brain monitoring for over 40 years, and in the early days, it was a very small group of people, and I had the honor to get to know and work with many of them. I worked with pioneers in intraoperative EEG and evoked potential monitoring, like Frank Charbot at Mayo Clinic, Mark Neuer at UCLA, and Keith Kappa at MGH. I worked for Britton Chance at Penn, whose work opened the field of NIRS monitoring for brain oxygen. I visited Wolfgang Fleckenstein in his factory in Germany right after he invented the Lycox. And the early pioneers of TCD, Rooney Oslid, Merrill Spencer, and Dieter Denner, were all friends of mine. And more recently, I've had the privilege to work with many of you who are shaping the future of neurocritical care today. So each week, I'll bring you a short 20-minute conversation with one of your colleagues who is helping to transform this field. So join my neural network. Details will be sent out in a newsletter soon. And now a brief spot for the annual meeting of the Neurocritical Care Society coming up October 14th through 18th in Vancouver. We'll be there in force, and we look forward to seeing our old friends and getting to know new ones. Our partner from IBM, Craig Maddox, will also be there. We'll be showing advances in our current products as well as new offerings such as CarePath and Cloud Connect. NCS has some exciting workshops the 2 days prior to the meeting. We are strictly not allowed to mention anything about the workshops since we provide equipment and they give out CME credits. I believe that's the reason. So check out the NCS website for details. Most of you know we are the data collection platform used in the Boost 3 trial. For those of you in the trial, we will have our team and a Boost unit configured with CarePath and a simulator in case you have any questions. And we are happy to talk to any of you making plans for an upcoming trial. So how can you find us at NCS? Go into the exhibit hall and head straight for the food. We're right there. And we want to keep up with your needs and suggestions. So fill out a very short survey, just 4 to 5 questions at our booth, and get a Starbucks gift card. Make that switch from the hotel coffee. And now we'll go live to Zurich.
Hello, everybody.
There you are. Great. How are you? Thanks again for that webinar. That was wonderful.
So good evening. I think I can answer the first questions which are addressing the clinical side. Very first one, we could answer both. How many patient data have you already collected? Systematically collected up to now are about 450 patients data, which represents about 4.5 million parameter hours. Then the next question about sharing our database. Actually, we don't. I think this will be the future, that we have globally some harmonized database. We can share our data, of course. Actually, what is possible, that I can't send you a selected set of patient data after signing a data transfer agreement. So if you send an email to me, I will answer you, and we can communicate about the conditions, because the data protection rules here in Switzerland and in Europe, they are somehow a little bit more strict than in the US. But send me an email to Emanuela .keller@usz.ch. The third question, do you think your algorithms change treatment in daily clinical practice? I think the answer is yes, but it takes time. So our very next steps will be that we have to validate our algorithms on other data sets, and actually they have to be implemented into the online data stream. But I think we have many decisions in intensive care treatment today which are made empirically, just based on experience and knowledge of the medical staff. And in future, I think decisions will be made more based on harmonized data sets which allow for clustering and to identify the specific case of every single patient. The next question is a technical one, and is for Chris.
So can the access and display of combined data be made platform agnostic? Researcher, nurses, physicians could view and do key processing on data and many different platforms: Windows, Unix, Mac, iPad, iPhone, Android, etc. Neuro ICU nurse on hot date gets interrupted and can view and interact with critical data from restaurant. Her date is very annoyed, but the life is saved. So I'm not sure if I get the question right, but so basically we are working on a new web front end. So it's web-based and can be displayed on any iPad, Android, or Mac, or also Unix systems, of course. And then, yes, so we are actually, we can, even now, we are able to stream the data to a mobile device. So far, we don't allow this outside of the US, of our hospital, of course, based on legal reasons and data protection reasons. But technically, ICU Cockpit is able to do that. And yes, if you go to a meeting as a doctor or a medical doctor, or are on your way home or to the hospital, so you could get events and see the live stream if you really want to, at least from a technical standpoint. I hope that answers your question.
So the next statements are more compliments, and there is much praise. Thank you very much. This is very motivating. And then there is a question asking about TCD for SAH patients. Is it the standard for their management? I have to answer yes. In our ICU, we perform daily TCD measurements. We are measuring the mean blood flow velocities, Lindegard's index. But I have to mention that these data are not really automatically integrated in our IT system. Up to now, we just have to insert them manually in a specific annotation tool we have set up by ourselves. So we have developed a so-called clinical data annotation tool in which we insert the data from the medical history of the patient and values from the imaging, for example, CT findings, MR findings, and TCD findings. Because these tools are not yet connected automatically to the system. But we perform the TCD measurements daily in the SH patients to have a measure for the risk to develop really delayed ischemic neurological deficits. And last question, once you are using a web-based interface, becoming platform agnostic is much easier. Perhaps this is a technical issue, Chris.
I have to admit, I guess I don't understand exactly what you mean by platform agnostic.
Perhaps you can concretize again a little bit your question. Otherwise, I think these are all the questions answered, hopefully. If not, please write an email either to Chris Sträßle or me. We will be happy to answer them.
This is Dick. I just wanted to comment and also ask a question. When I visited you, I was so impressed at it, I guess what you could call are these spin-off projects. And I'm wondering, when you started this project, you probably the mission was probably just to do better management of patients. But when I visited, and there's an amazing number of collaborators, both as students coming through there. You're working with a number of universities now on things like human factors. There's new products being developed in your environment there, and it surprised me. And I'm wondering, did you expect this, or is this, or did you plan for this?
No, not really, but I think it is not only an ideal platform for the clinicians, for clinical users, it is an ideal platform for medical device companies as well at the end. So, for example, we have collaborated with a startup company to develop a new device applying near-infrared spectroscopy for cerebral blood flow measurement. We are collaborating with pharmaceutical companies as well, because this data collection system is very helpful to perform clinical studies in the ICU environment. You don't need anymore the conventional case report forms. For example, the ethics committee and the regulatory authorities here in Switzerland today accept our automatic data collection as a case report form, because the conventional systems, as for example in Europe we have quite frequently the SECURE trial. I think in the US you have the red cap for as a case report form. They are not really fitting to the demands if you collect a huge amount of data. It's not working anymore. And therefore, to have this infrastructure is an ideal environment for companies to realize medical studies as well, clinical studies.
Yes, and I was so impressed when I saw what you were doing. And so I want to really thank you for taking your time to be with us today. And I certainly enjoyed your hospitality when I was over there filming this. And hopefully we'll see you at the Neurocritical Care Society meeting or some other meeting soon. Any final questions? Did they come in or?
No, I think we got all of them. So The last one was from John Baxter about the platform agnostics, and he just meant if it's able to run on any platform. And I think, yes, I mean, at least the front end is, you can stream the data to any platform. The back end is, of course, not. You need a whole server environment so far for the algorithms and live streaming of that much data coming in. But yeah.
All right. Well, thank you very much, and thanks for staying up your evening and joining us. And we'll be connecting with you again, I'm sure, later to get an update on what you've done. We'd love to do that. Thank you very much.
Thank you, and have a nice day. Bye-bye.
Thanks. Bye, everybody.
Bye.